All right. Welcome back for day two. Basically, our geometry when we're talking about three-dimensional shapes and two-dimensional shapes. So yesterday we talked about um, slicing and rotating. So taking two-dimensional shapes, rotating it into three-dimensional. We also took a three-dimensional shape and we cut it in half. So now we want to be able to find area and volume and stuff with a focus on volume a lot of in this lesson today. All right, but first off, let's look at this. Something that you should know. How do you find the area of the circle? Now, one of the things is you've got to know what the formula is. Area is pi r squared. If you don't put that in your memory bank, you've got to remember it. Well, notice what this needs. It needs the radius. So if I'm going to find it, now be careful. If they ever give you the whole line, they give you the diameter. So here, if the diameter is 8, what is actually the radius? You divide it in half. 8 divided by 2 or divided in half is going to be 4. So here, if I'm finding this volume, I'm going to do this. Now, in middle school, you use pi equals 3.14. Let's not do that here. We're just going to leave things in terms of pi here. So here I can square 4 and I get 16 pi. All right, now if this is feet, if it's area, it's squared. Now I can find it as a decimal, but we're going to also focus on different things about rounding. Now, I might just give you, hey, round it to this, or it may actually say it. So pay attention, especially if it says it or if I ask you to do it in a certain way. All right, you can plug in 16 and then pi is if you hit the second button and then this button right here, the caret symbol. So second and the caret symbol. And there's pi and we can press enter. So if I round it to the nearest tenth, think 10. 10 has 1 0, so I'm rounding it to one decimal place. So 5 point, and there's a 6 behind that too, so I'm going to round that up to a 3. Okay. All right, now another thing we're going to find is volume. Well, what is this figure? This is a cylinder. Okay, so here we go. The volume equals, if you don't know this, it's pi r squared h. So here, what did I have to have? All right, well, I have to have the radius. Again, they gave us the diameter, so here the radius is 4. And we also have to have the height. Okay, so for a three-dimensional object, you're going to have like another dimension. All right, so this is pi times 4 squared, okay, times 10. Now, if you're just doing it in terms of pi, only plug the numbers in. So 4 squared times 10. I'm not going to actually plug in a decimal. All right, and I get 160 and I put pi, or I'm not plugging in pi, sorry. Now, when we talk about volume, it's our dimensions cubed. So in this case, feet cubed. So just know that. Now, if I want it in terms of pi, as a decimal, it's here. Now, if I round to the nearest hundredth, think 100 has 2 zeros, so 2 decimal places. So 502 point, and 2 decimals is 6.5, and there's a 4 behind that 5, so that 5 stays the same. Now, we have a question down here. By the way, we're on page 23. All right. How are the formulas for the area of a circle? I'll write it down here. And the area of the cylinder related. The volume of the cylinder related. Okay, well, look, do you see that the area of a circle is inside the volume of the cylinder? Okay, so we see pi r squared there. It just gets multiplied by a different dimension. We had to have one more dimension to find the volume than we did to find the area of the circle. But you still had to know the area of the circle times the height is the volume of the cylinder. All right, let's move on. Flip over to page 24 and let's look at the warm-up on this page. All right, we've got two solids here. What information would you need to calculate the volume of each solid? Now we got to go back in our memory bank. You may have to Google something, but as you start learning these things, make sure you start putting them up here and memorizing it. So here, this is a cylinder. All right, you have to be able to identify that this is a cylinder, and you would have to know what the formula is, pi r squared h, which we just saw. All right, well, what is this figure? It's a rectangular prism. You have to identify it's a rectangular prism or a box. Well, how do you find the volume of a box? Well, if you know the length, the width, and the height, then you know what it is. All right. It says, what is the same and different about how you would find the volume of each solid? All right. Here, you need pi in the cylinder. Here, you just need the 3 different dimensions. Here, you kind of need 2 dimensions here, but you use that r twice. That's the reason why it's squared. Okay. So let's look further down on the page. And they've added in numbers into this. All right. And I added the question, what is the volume of each? All right, so the volume was pi r squared h here for a cylinder. Okay, just double check. Did they give us the radius this time? Unlike the last picture, they gave us that diameter. Yes, they did give us the radius. They're only showing us half. Okay, so pi 6 squared. All right, now the height is how tall it is, basically from circle to circle. Now, sometimes this can be laying on its side. So height doesn't always mean up and down. So just be careful. In a cylinder, it's from the top of our circle to the bottom of the circle right here. And so that's 10. Now, I'm just going to write this in terms of pi. So when I write this in terms of pi, I'm again, just a reminder, I'm plugging in only the numbers like I did here. All right, and I get 360. So this is 360 pi. All right, now here was the volume of a box or rectangular prism, length times width times height. So here we're doing 10 times 4 pi times 9. Now, if you want to write this in terms of pi, again, only multiply the numbers. All right, so here I'm just going to plug in 10, all right, times 4 times 9. All right, and that is also 360. So all these are different shapes. These have the same, whoops, I forgot to put pi back in my answer. Make sure you do that. These have the same volume. Different shapes can have different or the same volume. All right. So here we go. Here are 2 containers, all measures. These are the same containers that we were just talking about. All right. Suppose the prism contains water that reaches a height of 1 centimeters. Okay. So here we're changing it. We poured water into here. Okay. So we poured water, and this water is only 1 inch tall. All right. So we're talking about this water right here. Okay. So we're not talking about the whole thing. All right, it says the water is poured from the prism into the cylinder. What is the height of the water in the cylinder? Okay, let's think about this for a second. What is the volume of the water? The volume of this water is going to be 4 pi times 9, and we change the height from 10 to just 1 inch right here. Now, you should be able to multiply these numbers. 4 times 9 times 1. I'm just leaving it in terms of pi. It just makes it a lot nicer like this. And I get 36 pi. All right, so the volume of this water is here. Well, what if I take this out and I pour it in here? Okay, and I pour all the water in here. Their question is, well, what's the height going to be? All right, well, the volume of the water stays the same. Okay, now our figure is different, so our formula is different. Okay, so I did this right here. So our volume is still going to stay 36 pi. All right, our radius, if we go back up here, what was our radius? It's 6. Now, the 10, all that water is not going to reach to the top of that cylinder. So we're trying to figure out what is this new height right here. Now, I want you to look right here for a second. We want to solve for h this time. Not all of the time are you going to be finding volumes. Sometimes you have to solve for a certain dimension. Well, let's go ahead and kind of clean this up. Do you notice how there's pi on each side? This is why I left it in terms of pi. Because in some cases, not all cases, you can divide by pi right here. And I get 36 equals, now that's 36h right there. Now, how do I solve for h? All right, I divide by 36. All right, well, what's 36 divided by 36? 1. All right, so the height, and these are in centimeters, the height also in our cylinder is also going to be 1 centimeter. All right, now let's jump down to number 2 down here. They're changing it up a little bit. Suppose the height of the prism contained water that reached a height of 3 centimeters instead. So let's say this water right here, all of this water reaches 3. Okay, so we want to do the same thing, but this time our volume is going to be 3 times 4 pi times 9. Now, you can take a calculator and multiply just the numbers, but we can also do this as well. What is 3 times 4? 12. 12 times 9 is 108 pi. So this is our new volume right here. Now, remember what I said right here. When I pour it into here, I want to know what that new height is. We don't know what that is. Now, our radius still stays 6. All right, so I'm just going to write our formula, pi r squared h. The more you write it down, then you'll remember it, because these things you have to remember. All right, so the volume 108 pi equals pi. Okay, our radius is 6 squared. And then our h, okay, our height is just h, because we don't know what it is. It's not 10, because that might not reach up to the top. All right, so here we go again. Okay, let's go solve this. Now I'm going to go ahead. Whoops, it's 108, not 180. I'm going to go ahead and change that to 36 pi. And if you notice, do you see how you have pi on each side? So let's divide pi out. All right, so 108 equals 36h. And so now let's solve for h. We're going to divide by 36. All right, so when we take our calculator, what is 108 divided by 36? All right, 108 divided by 36 gives us 3. All right, so here, our height is 3 centimeters. All right, so let's move on. Sorry, I had a sheet of paper fall. Okay, so we're on page 25 right now. Okay, and we're completing activity, or we completed activity 1. Let's flip over and let's go on to activity 2. Now, so they gave us the actual figures there, those 3-dimensional figures. Now, let's think about what we did yesterday. Suppose each 2-dimensional figure is rotated around the vertical line shown. I'm going to start with this one. All right, so let's think about it. If I rotate it, all right, think you're going to reflect it. So it's going to be the same, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So it's going to go all the way to here. All right. Now, remember what I said yesterday, rotating, what type of motion is this? Circular. All right, so here we're making circles right here. All right, this 3-dimensional object right there. All right, and actually, let me fix this right quick, right here. Really what's happening is this is going back like that. There we go. All right, and so we actually have this thing right here. All right, well, really, what do we have? We have 2 cylinders. We have a small cylinder on top and a bigger cylinder on bottom. Okay, so small cylinder up top and a large cylinder on bottom. Okay. Now we want to find the volume, and that's number 2 down here. You just can't see it in my whole screen. So now I'm going to find the volume of this. If I want to find the volume, all right, again, you're going to have, notice what we've got. We've got a small cylinder, okay, but we're going to add it to the large cylinder. Okay, now we have formulas for cylinders and we've already done it, pi r squared h, and this one's also pi r squared h. It's just this time the radius and the height might be different. Okay, so let's just talk about this one right here. All right, the small one. Now, one thing is you got to be able to pick out that radius. That radius is only half of this circle. I'm doing it in orange right there. How big is that? 2. So 2 squared. So that's a 2. And then our height runs from here to here. Well, how much is that? That's 3. All right. So let's just write this in terms of pi. 2 squared is 4, and 4 times 3 is 12. Again, if you want to multiply, put it in your calculator, feel free. All right, plus. Now let's talk about the large one. Well, you're going to have pi. Now let's look at its radius. All right, its radius right here runs from the middle to there. So basically the axis of rotation. So here, this is 1, 2, 3, 4, 5. All right, so our radius is 5 here, so I'm going to put 5 squared. And this time our height runs from here to here. You're just counting these boxes that are solid. 1, 2, 3. All right, so our height is actually the same thing. It didn't have to be, but it just so happens to be. All right, so here we go. 5 squared times 3. All right, 5 squared is 25. 25 times 3 is 75. If you need to throw it in your calculator, feel free. And now here you can add these together. They're kind of like terms because they both have pi. So 12 plus 75 makes 87 pi. That is the volume of that figure. All right, so now let's talk about our next figure. Now here I'm rotating around this line, but do you see how there's space right here? We still want to leave that space. All right, and when we rotate it, it makes a circular motion like this. All right, here we go. Okay, well, what do you notice about this one? Do you remember that toilet paper roll that I mentioned yesterday? This is like a cylinder, a large cylinder minus the small cylinder. Oops. A large cylinder minus the small cylinder. So to find its volume, this time we're subtracting. Anytime you have to take something out or cut it out, you're going to subtract. Here, in the first one, I placed it together, so I added. Okay, here, still a cylinder, so pi r squared h, right here. But focus on the large cylinder first. Now, the large cylinder, you still have to go out from the rotation to here. That is the radius of it. All right, so that radius, 1, 2, 3, 4, 5. So pi 5 squared. Now the height is this part right here. All right, so the radius is 5. The height is 1, 2, 3, 4, 5, 6. Now I am going to throw this in my calculator just to kind of reiterate and show you guys. Just plug in the numbers 5 squared times 6. I'm not plugging in pi. So I get 150 pi. Leave pi in your answer. But this time I'm subtracting. So the small pi. All right, let's think about the radius of it. The radius of the small one runs from here to here. Okay, so 1, 2, 3. Now the height's still the same. The height of that small cylinder in this case is still the same. It's still 6. All right, so pi, and this is 3 squared. The height is 6. So pi 3 squared times 6. Okay, so 3 squared times 6, like that. So, oops, I get 54 pi. And here, I just want to subtract. So you can do 150 minus 54, and you get 96 pi. So we're still able to find the volume. This is actually connecting what we did yesterday and what we're talking about with volume. You have to take a two-dimensional shape, rotate it into a three-dimensional shape, figure out what those shapes are, make sure you have the formulas, and find all the pieces. Make sure you can tell between adding and subtracting. All right, move on to page 27. Okay, given a cylinder with radius r and height h. Okay, let's draw that. Okay, radius r and height h. So there we go. Write an expression for the volume of each of these changes were made. The height is tripled. Now, for right now, the volume's pi r squared h. We have r and h. But this time, if the height is tripled, that means you're timesing the h by 3. Okay, and the radius remains the same. Okay, so the radius remains the same, but the height this time is 3h. Well, what does it do to our volume when we triple our height? Well, if you notice, we don't have anything. That 3 can come out here. It basically multiplies our volume, what we had originally, by 3. Now what happens when we triple the radius this time? Okay, and make it 3r. Now realize this is squaring that whole thing this time. And then the h remains the same. So watch what happens this time. Well, when you square the 3, it makes it a 9. All right, so here, 9 pi r squared h. So now it took pi r squared h and times it by 9. So just because we're tripling the radius doesn't mean it triples the volume. All right, it actually times the volume by 9 when we do that. And the reason is because it actually gets squared in here. Now, let's look at number 2. Given a cube, okay, I'm going to draw this. A cube has all the sides alike, like this, and it says S. Each side is S. And remember, cube, all the sides are the same. Write an expression for the volume of the side length. We're tripled to 3S. Now, first off, in a box, what's the volume of a box? Side times side times side, which is side cubed. Now, what happens when I triple each side? Multiply each side by 3. So 3S times 3S times 3S. All right, well, what happens? 3 times 3 times 3 is 27. And then we still have S cubed. So if you notice, it actually, when we triple all the sides, all right, it doesn't just multiply the volume by 3. It actually multiplies the volume by 27. All right. So which change affected the shape's volume the most? Which one affects the least? All right. Well, here, anytime where it changes all the sides, of course, it's going to affect it a lot. But when we go back up to the volume of a cylinder, what affected it the most? When I change the radius, it affected it the most than when I changed what the height was. All right. So now let's flip over to page 29. We want to look at activity 4. All right, so 29, activity 4 right here. All right, now for each pair of solids, decide whether the volumes of the two solids are equal. All right, now here we go. We're going to figure out if they're equal. Guys, start using your volume formulas. Okay, pi r squared h. Okay, so this is pi. Now, I want you to look at this. Do you notice how they gave you B? What this stands for is the area of the base. Now, remember in the warm-up, we discussed that in the volume of a cylinder was the area of a circle. Do you see right here, the area of the circle is 12? This is the area of a circle. Okay, and then the height is 6. So this, when I multiply it, comes out to be 72. Now let's look at this one. How do you find the volume of a box? Length times width times height. And if you throw this in, 4 times 3 is 12. 12 times 6 is 72. These have the same volume right here. All right, now let's look at this one. Now, by the way, this is still a cylinder. This is called an oblique cylinder when it leans to the side. We still use the same formula. It's pi r squared h. All right, so here we go. So pi, our radius here is 3, but this time our height, it's not the 10. The height is where it comes from the top down to the bottom at a right angle. So this is 7. All right, let's leave this in terms of pi. All right, when I do this, okay, 3 squared, whoops. Okay, 3 squared times 7. Oop, let me delete that plus sign. And I get 63 pi. All right, now here, this is pi r squared h. All right, so pi 3 squared times the height of 10. All right, some of you may already know these are different. Okay, this gives me 90 pi. This one right here is greater than the one that's upright is greater than the one that is oblique. All right, let's flip over. I got a couple more that we want to find the volume of. Now we're going to run into some pictures we haven't seen before. Like here we have cones. Now the volume of a cone is pi r squared h, just like a cylinder, but we divide by 3. All right, so here pi The radius is 3 squared. The height is 5. The height always comes from the vertex down at a right angle. Okay, how tall is it from that point down to the base? All right, and then we divide by 3. So when I plug this into my calculator, okay, I'm just going to plug in the numbers. Now, if you're curious how to plug in a fraction, if you do alpha x right here, alpha x, all right, 3 squared times 5, okay, and then arrow down and you put 3. So this makes 15. Don't forget to put the pi in there. Now here, this is going to be pi. The radius is 3 as well, and the height is 5. Don't forget to divide by 3 because it's a cone. And we notice this is going to be the same thing. That's going to multiply to be the same thing. So these two have the same volume, even though they look a little bit different. Now, let's look at this one. Now, I'm going to start off with what I know. I know the volume of this box is going to be length times width times height. So 5 times 1 times 6. All right, so when I multiply that, that is 30. All right, now this is a triangular prism. Okay, so a triangular prism we haven't talked about, but if you actually kind of look at it, doesn't it look like half of a box right here? It's like taking a box and you're cutting it on its diagonal. All right, well, it's like the length times width times height divided by 2. Well, the length and the width describe the rectangle, so 5 times 3. The height talks about how high that triangle actually is. In this case, it's 4. And divide by 2. All right. So again, just to recall how we get the fraction, if I say alpha x, and I say 5 times 3 times 4, and then I arrow down and get 2, and I get 30. Are the volumes the same? They are. So two different figures can have the same volume. And remember, volume is how much something holds. So if I poured water into these figures, these two figures are going to hold the same amount of water. All right, now, pyramid. This is a pyramid right here. Okay, in this case, it's actually a square pyramid. All right. Now, the formula for the volume of a pyramid is big B times H divided by 3. Just like the cone, we divide by 3. But what does that big B stand for? Area of the base. Okay, that means if it's a square, you got to find the area of a square. If it's a rectangle, find the area of a rectangle. If it's let's say, a hexagon, you got to find the area of that hexagon and then multiply it by the height of the figure. Okay, so here we go. Square pyramid. Here, I know this one doesn't look like a square, but because they put 5s, it is. All right, here, the area of the space. How do you find the area of that? It's 5 times 5, which is 25. So now I can plug it into that formula. 25 times height. The height is from the apex to the base. This one just so happens to be upside down. So times 5. But don't forget to divide by 3. Okay, so when I do this, 25 times 5, and then I divide by 3. All right, now it did come out as a fraction. If you want it as a decimal, just type in 125. Use the division symbol divided by 3. If you want a decimal, you can do like 41.67. That'd be to the nearest hundredth spot. Okay, so let's look at this one. All right, the volume, again, area of the base, 5 times 5, which we just said was 25. The height is 5, and divide by 3. Because I'm multiplying that by the same thing, and it looks like those are going to be the same. All right, now, these are two completely different figures. This is a cylinder, and this is a cone. All right, so a cylinder, pi r squared. Now, just double check. They gave us r and not the diameter, and they do. All right, 2 squared is 4. 4 times 6 is 24, and it's pi. All right, and then this one, a cone. The volume of a cone is pi r squared h divided by 3. All right, so pi, the radius is 2, so 2 squared, and then times 6. All of that divided by 3. So just plug in the numbers. All right, 2 squared times 6, and then divide by 3, and I get 8. This equals 8 pi. And obviously, the cylinder has a larger volume than the actual cone. When they have the same dimensions, The cylinder is always going to be larger than the cone. All right, one last thing, and grab a sheet of paper, and we're going to write down all these formulas. Some of the formulas are ones that we haven't come across, but you're going to need to memorize. All right, so I'm going to quickly go over these. All right, for you. And again, you need to memorize. Volume formula, rectangular prism. This is our box. The volume is length times width times height. All right, triangular prism. Triangular prism, remember, looks something like this. Okay. The volume is length times width times height, but we divide it in two. It's basically triangular prism is half of a rectangle. That height is talking about the height of the triangle. The length and width is basically, your length and width is going to be whatever makes up that rectangle right there. Okay, any prism, whether I have a triangular prism, a rectangular prism, you can still use this next formula. The volume formula is actually big B times H. All right, big B in any of these formulas stand for the area of the base. Okay, so if I had a pentagonal prism, you would have to find the area of that pentagon and put it here, and then times it by the height. The height would be the distance between those two pentagons. Now, cylinder we worked with a lot today, pi r squared h. You should have that here already. Okay, we wrote it down several times. Pyramid. Pyramid is very similar to prism. The only difference is pyramid always comes to a point. Anytime it comes to a point, you're going to take that formula and divide by 3. So big B times h divided by 3. And that big B is still the area of the base. Now, a cone is just like a pyramid. Okay, a cone actually, and if you think about it, what's the base of a cone? A circle. And we did say the area of a circle. The area of a circle is pi r squared. All right, then you times it by h divided by 3. Okay, that actually just looks like the cylinder, just divide by 3. And then the sphere, 4/3 pi r cubed. All right, I am going to add in a hemisphere. A hemisphere is half of a sphere, half of a ball. And just think of it. If it's half of a ball, what am I going to do? I'm just going to divide by 2. All right. And let's look at one last problem, page 39. Okay. We're going to look at 3 figures and we're going to find the volume using these right here. Okay. So here's our 3 figures. Okay. Find the volume. You may want to pause this, use your formulas. All right. And come back to it. This is a cylinder, so pi r squared, so 5 squared times 5. I'm just going to leave it in terms of pi. All right, 5 squared is 25. 5 times 5 is 125. And then leave pi in here, centimeters cubed. All right, now this one. This is a cone. The cone is pi r squared, so 5 squared times a height of 5, but then I divide by 3. All right, now I'm going to leave it in terms of pi and just show you something right here. So if I do 5 squared times 5, and you don't have to use the fraction formula if you don't want to, divided by 3. It's just if it ends up like this, to write it out as a fraction, hit math button and press enter and enter again, and it changes it to a fraction. I'm just going to write 125 pi divided by 3. So if you notice, these have the same dimensions. It's just you're dividing that by 3. All right, and then this time it's a sphere. A sphere we haven't done yet, but I just gave you the formula. It's 4/3 pi r cubed. Now be careful. If I give you a whole line, what is that? The diameter. All right, so what does the radius equal? Half of it, 5. Okay, so we're going to put 5 cubed. So the radius is actually 5 cubed. Now, when I plug the numbers in, let's look at this. Alpha x does the fraction, so 4/3. And then I'm going to put in 5 cubed. Okay, and to put in cubed in this calculator, now you can do any of these in Desmos. I'm just using this calculator because it's easier. Use this caret symbol, raise it, and you'll see it popped up right there, and put a 3 in. Now this makes 500 divided by 3. Just don't forget the pi because we did not put the pi in. And all of these are centimeters cubed. And you can see the differences here in these. Now, if I took 500 and divided by 3, I get 166. This one's actually larger than that one. And then this one's larger than that one. So as far as volume, the sphere is the largest, the cylinder is the next largest, and then the cone is the smallest altogether. All right. Make sure you know how to use these formulas, find the volumes. Make sure we did take a look at taking a two-dimensional figure, changing it to a three-dimensional figure, and finding the volume there as well. So we've got to do all of those things. All right. Be ready. We're going to continue with volume tomorrow. So be ready to knowing these formulas and knowing how to use them.